For slope, give me one case of slope. Allie, what do you have for slope? One case of slope.
It's increasing or growing.
Say again?
It's increasing or growing.
So she said it's increasing. What kind of number would it have to be for it to be increasing, Allie?
A positive.
A positive. So if the slope is positive or bigger than 0, you have an increasing line. So slope is a number. It's a number that makes the graph rise, or it's a number that makes the graph fall. If the number is positive, it increases or rises from left to right. Just like you read a book, you read the slope the same way. So that's one case of slope. How about the second case for slope? Dylan.
Jacob.
Jacob. I don't know why I called you Dylan. Jacob. Jacob. Dylan.
Negative.
Negative. Sorry. And Jacob, if it's negative, what would happen with the line?
Decreasing from left to right.
Yeah, it's going to be decreasing. Alright, so now we have two options, a line that goes up or a line that goes down. But there's still two other lines. Quinn, do you know one of the two other lines that exist besides the one that goes up or one that falls down? Yeah, so one that's just straight, going left to right. What kind of line do we call that? Horizontal. So we could have a horizontal line. It's flat, goes left to right. What happens with the slope of a horizontal line? Do you know, Quinn? What must the slope be to make the line horizontal? 0, yeah. So the slope would have to be 0 because it's not going up or down. That's what's forcing it to go left or right. So if the slope is 0, think of being at the beach, the sun going into the horizon. The sun is my slope of 0, falling into the horizon, which is horizontal. So a horizontal line has a 0 slope. One final case of slope. So it increases positive, decreases negative. It's 0. For Connor, it could be
Undefined.
undefined. And Connor, what type of line would you have if it's undefined?
Straight up and down. Vertical.
Yeah, vertical line. So a line that goes vertically is rising, but it's not running left or right. So that's when I would have any number divided by 0. Because I could rise 5, but I'm not going to go left or right. So I just continue to rise, and that's what makes the vertical line. So those are 4 different options for slope to create the 4 different ways you can graph a line. There's one other vocab term underneath there, and I'm actually going to add one with it. So you see the word slope-intercept form, but there's also point-slope form. Slope-intercept form is the one that we talked about back in chapter P. That was day 2 of school when we did basic graphs. We did those 6 graphs. And we said slope-intercept form, Dylan, is y equals mx plus b. M is the slope, the movement of the line. B, you begin with B. Slope-intercept form is how we graph a line. But point-slope form can be used to write equations pretty easily. Does anybody remember what point-slope form is? This is the one I actually prefer if I'm writing an equation. Kevin, do you remember?
Is it y2 minus y1 equals m times x2 minus x1?
You're so close. Like super, super close. Jacob.
Is it y2 plus y1?
Not quite. Abby. These are all like close. It's y minus y1. This is the variable that remains in the problem. The y1 represents the point you're going to use. And then m, x minus x1. So the x and the y remain in your equation so that when I plug in my point and the slope, hence point slope form, we still have that x and y remaining because an equation has to have x and y. So if I know a point, I can plug in the point and the slope, and then we can have the equation of a line. So point slope form, when you have a point and a slope, you plug in information, you have the equation of a line. So we already have two problems that we're actually going to do today. Well, like 2.5. The rest is kind of just like vocab, getting you to understand what everything means. But this first one is an application problem. And it talks about research in motion in the year 2006. They had net profits, which is how much they made for that year, $631.6 million. It's not too bad. In 2007, just 1 year later, their profits were now $1,293.9 million, which is actually $1 billion. So they went from having a profit in millions to a profit in billions, which is pretty good for that company. It says to write a linear model to give the net sales in terms of years. A linear model is the same thing as saying an equation, except we're modeling information from the problem, hence we're writing a linear model. When you're writing an equation, what's one thing that you need to find? You're trying to write a linear equation or a linear model. Slope. So we need to find slope. That's pretty important to know what the slope is because we need to know how fast is the line rising or falling. And then of course we need the y-intercept. Those are the two things we need. We need the slope and the y-intercept. So when you go to do an equation of a line, do not ever use the actual year because the year 2006 is really a number. It's not a year. And yes, it is a year, but in math it thinks it's a number. We will always use numerical values to represent years. So I'm not going to plug in 2006, but if this is my initial year, then I'm going to say that that year is 0. Unless it states otherwise, the initial year is always year 0. So we will never use an actual year value and plug that in. We use a numerical number to represent it. 2007 is just 1 year later, so then I would say 1. But if it was 2008, then it would be 2 years later, so we would say 2. So we will never use the actual year. We'll always use a number to represent it. So calculate the slope by knowing that we have at 0, which is the initial year, that's how much money the company made. And you don't have to put in all the zeros. That's what the word million is there as a label. And then at the year 1, we have the 1293.9. So y2 minus y1, and then x2 minus x1. Because it's just a change in a year, the denominator is just going to be 1. Really, we're just looking at that y value. Time is always x, always independent. Everything depends on time. So Odette, what would the slope be?
662.
Good. And again, that's in millions of dollars. So we have the slope. We're trying to write the equation of a line. Now we have the slope, where we're trying to write a model. What's the b value? Without doing any work, just think about it. What's b? What does it mean to have a y-intercept? Taylor?
641.6.
Yeah. That's our y-intercept because the y-intercept is when x is 0. So, adding this to my problem, 631.6. So we have the slope and the y-intercept. Didn't need to do any work to find that because you have the initial value. So we have our linear model. We're going to use that to estimate the net sales in 2010. What would you do to estimate the net sales in 2010? Right? Yeah. So 2010 is 4 years after the initial 2006 year. So we would plug in a 4 for x. Guess you might need a calculator for this. what was the net sales in 2010, Maggie?
3,280.
And then she quietly said million. I put a dollar sign with that as well because we are talking about sales profits. So put the dollar sign there. So what number is this actually? Kevin?
3,280,800,000.
So 4 years later, they're now making $3 billion dollars instead of starting with the 631 million. You don't have to write it like this. You can keep your answer like that there. Just make sure you apply the word million after. Questions? So there are 3 other vocab words down below, and it's more just kind of remembering what type of equation is associated with the type of line. So the first one says general form. Right here I just gave you slope-intercept, which is generally the graphing form. Point-slope is kind of how we can use to write an equation. And then general form is yet another way that we can kind of think about equations. General form helps us get x and y intercepts really easily. And every equation that we do this year, we'll look at a graphing form and a general form. Anybody know what the general form looks like on a line? Evan?
AX plus BY equals C.
You may have also seen it as ax plus by plus c equals 0. Either one of those are considered general form. I'm not sure which one the book has.
If that's the case, then why wouldn't like it be negative C?
Because it's arbitrary. Because the a, b, and c can be any number. They could be a positive 3. It could be a negative 3.
Oh.
So like saying it's a negative versus a positive when they could be any number doesn't really make a difference. Good question. The other 2 words down there are the types of lines. So we said vertical lines have a slope that's undefined. What would the equation of a vertical line look like? So think, you have this vertical line. What would the equation of a vertical line look like, Jacob?
M equals A over 0.
Your slope would be a over 0. But what would the actual equation of the line be?
Y equals A over 0 x plus B.
Okay.
X equals.
Yeah, x
Oh.
equals and then a number. And again, a is any number. You were on that
I
track.
was thinking too hard.
So if you have a vertical line, it has to go through the x-axis. Well, if it's going through the x-axis, then it has to have x equals something. Any number. X equals 5, negative 10, 15, but it's x equals that makes that a vertical line. And then if it's horizontal, it has a slope of 0. Remember our horizon. So Odette, if it's a horizontal line, then it would be in the form y equals. I'm going to use a b instead of an a, just to show that it can be a different letter. Last year, depending who you had, a vertical line has an undefined slope, and the equation is in x equals. That's supposed to be here. So Vox, vertical, undefined, x equals. Hoi, like ahoy matey, we have a horizontal line. My slope is 0, and my equation is in y equals form. So every horizontal line has a slope of 0, which means my equation has to be y equals. So the slope of 0 is going over the horizon. Questions? I know you think that this is basic. Guaranteed 5 of you still get it wrong on the test. I don't know why, it still happens. So whatever I can give you to try and get to remember, so that you get it right. That happens. Everybody flip-flops them. All right, the last thing that we're going to talk about today will be the last question of that little reading check quiz. Parallel lines versus perpendicular lines. Mackenzie, what do you know about the slopes of parallel lines? Yeah. So parallel lines have the same slope. And she said they're equal to each other, so the slope of line 1 must equal the slope of line 2. That's what makes them parallel. They're rising or falling at the same rate, so they'll never cross. They're parallel. Perpendicular lines is what that last question was asking. What must the slope of perpendicular lines be, Maggie? Say it again. So she said opposite. That's the opposite part. Rebecca's going to help you behind you. Right. They have opposite reciprocal slopes. Rebecca, what does that mean? Can you give me an example?
Yeah, -4 and 1/4.
Yeah. So the opposite part, positive versus negative, negative versus positive. The reciprocal part, they should be flips of each other. So opposite reciprocals. There is a property with perpendicular slopes. So Mackenzie told me parallel slopes, they have to be equal. M1 must equal M2. But perpendicular slopes, if they're opposite reciprocals, when you multiply the slopes together, every single time they're going to equal one number. What's that number that they equal, Kevin? A -1. No matter what two pairs of numbers that you're combining together, if they're opposite reciprocals, they always multiply to be -1. Their product is -1. So that's the property that goes along with perpendicular lines. Their product should be -1. Parallel line slopes should equal each other. So there is one more problem on there. It has a part A, part B, so I guess it's technically 2. But dealing with parallel versus perpendicular lines, it wants us to find an equation of a line that passes through a point. So the point, if we're using that point slope form, that's like our x1, y1. And part A says parallel to this line, part B says perpendicular to this line. So what do you think you'd have to do first? Maggie? We need to solve for y. We need to know what the slope is of the current line that we're working with so that we can get the slope of our new line. So we have to solve for y. So take the 2x over by subtracting it. Divide by -3. Be careful with those signs. You got a negative, you're dividing it by a negative. So that gives us 2/3 x minus 5/3. So that's the line that we're looking at. So if I draw a little picture here, you don't have to draw the picture. Sometimes having a visual makes it a little easier to think about. So we have -5/3. It's just beyond, in between -1, -2. Slope is up 2 over 3. We'll say about here. So that's my current line. Our new line is supposed to pass through this point and have the same slope. Same slope. So here's my current slope. That means the parallel line has to have that same exact slope. I draw those two little lines diagonal slanted to represent parallel. I think in geometry they draw them up and down, but then it looks like the number 11. So I'm going to use point slope form. Point slope form says take y minus y1. Well, that becomes a +1 because minus a negative. That's equal to the slope times x minus x1. So point slope form, you have a slope, you have a point. You plug it in. And then you do a little bit of simplifying. Anybody know what 2/3 times -2 is?
-4/6.
-4.
Thirds.
So 2 times -2 is my top number. 3 is on the bottom. There's a 1 on the bottom there. So you multiply the top, divide by the bottom. And then if I solve for y to get y by itself, we have to subtract the 1. So 2/3 x. What's 4/3 minus 1? -7/3. Nice job. So your equation, 2/3 x minus 7/3. The last part of this question wants you to use the same exact line. So we still have 2/3 x minus 5/3. Here's the slope. But it says perpendicular. Maya, what would a perpendicular slope be if my current slope is 2/3? -3/2. So we're going to do the same thing, but we're changing the slope. So I would have y plus y1, still the same ordered pair. The slope is now -3/2, and then x minus x1. So slope is different because we're dealing with a perpendicular versus a parallel line. But you're plugging in the same ordered pair because I want that line to go through that same point. And you take -3/2 times -2, you get a +3. Questions? So when you're finding parallel and perpendicular lines, you're using just the slope of the original line, not the y-intercept, because you got a new point that you're trying to cross. So, volunteer to try 67, Quinn and Kevin 86. So Quinn 67, Kevin 86. Oh, I did 12.